Okay, we're back at the Moodle Rooms webpage. Again, my hope is at this point that you've clicked the link, that you've downloaded the notes. Now, whether you keep them on the web or you download them, let me just go through that with you. If you want to download them over here, download the notes. You can download them. All right. So I've already downloaded them to my computer. So if I wanted to, look at that document, which we're going to start on today, let me just go to that. Give me 1 second. And whoops, sorry about that. Just give me 1 second. So I downloaded this document to my computer. All right. So, I wouldn't worry so much about, you say, oh my God, there's so many pages here, I don't know what to do. You're going to go page at a time. And that's all we're going to do throughout the lecture, the page at a time. And where we are in week 1. So let me just go through this with you. Again, you need access to this document. This is week 1. You need this document. Let's click on it. It's a red link. It'll bring me right to week 1. What does it say? We're going to cover materials. Now, essentially what we're going to cover in week 1, which is going to be a short week, is basically solving an inequality. Now, what types of inequality are we going to solve in week 1? Linear, that means degree 1, and then higher degree polynomials like degree 2, degree 3, degree 4, yada, yada, yada. And we're also going to be doing what's known as rational or a ratio of polynomial. Now, these words should be somewhat familiar to you because it's what you studied in Math 100. So we'll cover week 1 and I'll cover it completely. All right. So when you're looking at the notes, what are you seeing? Materials covered. We'll cover basically inequality. At the end of the week, though, we're hoping that if you've done what I've asked you to do, which is pay attention, follow the examples, and do some supplementary exercises, we'll go through that in a second, you would be able to do the WebAssign. And the WebAssign would be the Math 119 week 01. I'm not sure if that's up yet, but again, you'll be updated in email when that gets there. Don't be overwhelmed by this, but you probably should be posting to a weekly discussion group, or at least coming by during office hours and discussing with me issues that you find important. All right. So, what we're going to do is we'll cover linear inequality. I'll tell you what the format looks like. On the sidebar, I want to point out in these sidebars, you see these little videos over here. If you click on these videos over here, I want to point out what happens over here. A video will open up. No, I'm not going to play the video for you, but you can play that video.
Okay, this is the same stuff you learned in Math 100. These are linear
I'm going to stop it.
inequalities.
And I'm going to close that out now. All right, let's go back to my notes. And there's a little video then again talks to this information over here. I'm still going to do it in lecture, by the way. But again, some students, the lectures go too fast for them. They have to look at these spot videos instead. That's fine. You can pause those things and watch them at your convenience. So after we go through that, there would be example questions that we will do together. When I say together, it's me lecturing. You're watching, I'm lecturing. I'm going through examples the way we want you to do it. You need to pay attention while I'm doing these examples. So someone's going to say, could you go slower so that I could do the examples? No, you're going to do examples later. But right now, I'm going to go through a lecture and then examples. We do this for 3 types of inequality. First, we do the linear, which is exactly what you did in Math 100. Then we do the polynomial inequalities. I'll go through a lecture on this one over here. I'll go to the whiteboard later. We'll talk about this. Again, for the students that want to watch a little video on the side, please do so. All right. Then we go through examples. What examples do we go through? These examples. These examples also have videos on the side. You're more than welcome to watch those videos if you need, but you're not required to. We go through those examples. Again, this is still in lecture format. So I'm talking. We go through the rational inequalities. Yep, we'll go through the examples. Again, in the sidebar, there's little videos over here. And then someone says, when do I get a chance to try? I've been watching you and I'm ready to try. It's like watching someone play a game. You say, when do I get to try? Well, we want you to try. So what are you going to try doing? The supplemental problem set. So the supplemental problem set, there's a bunch of problems now that you try on your own. And you want to try them on your own, right? You want to try these on your own. What about these examples over here, though? You notice there's questions and there's answers over here. I'm also going to post videos of me going through this for those students that need that. All right. So let me go how the format of the course is going to go. Let's go back over this again. This is week 1. No, we're not done with week 1. We're just starting it. So when you go back to week 1, someone says, oh, it's really long. I can't get through all that material in one shot. Well, it might take you a whole week to get through it, but we want you to get through the material. So what we're going to do now is we're going to switch to the whiteboard, and this is the way the course is going to run. You're going to see me talking about the notes and then moving over to a whiteboard. All right. And then I'm going to go through 3 separate lecture materials. Then we'll do examples later. All right. So let's talk about this now. Let's talk about me switching over. Here's the deal though. Once lecture's completed and you've gone through the supplementary exercises, you want to do the WebAssign. This is going to take a lot of work on your end. You have to do a lot of time spending listening to lecture, studying the material, working problems, and doing the WebAssigns. If you do that though, you really should have no problem moving forward in the class. All right. So what I'm going to talk about now is, going over the material, and I'll go over the material with you. Just give me 1 second to switch screens to a whiteboard. All right, you're seeing my whiteboard. All right, now what's nice about the whiteboard now is I can draw on the whiteboard. So again, we're really at the same section. We're just looking at this over linear inequalities. So, I'm going to go through, talking about it. The bottom line is your notes in front of you. There's no need to copy, but you should be listening. And at some point, you need to start to study and listen. But the first property I want to go through is what's called the transitive property. It's one we really don't deal with at Essex too much, but it's probably the most interesting property of inequality. And what does it say? If A is less than B and B is less than C, it implies that A is less than C. This is something that people need to think about. All right. It's a transitive property. But again, it's not something we really deal with at Essex. We don't really see it too much. We don't see this one either, the addition of inequalities. What does it say? If A is less than B and C is less than D, then A plus C is less than B plus D. This is something you probably need to think about as well. It's important you start to think. All right. I do want to point out this one here, which is the addition of constants, we use a lot at Essex County College. What does it basically say? That if A is less than B, you can add any constant you want to both sides of the inequality, and there will be no effect on the inequality. And this is very important. So this is important. We use this a lot at Essex County College. We see an inequality and we add something to both sides of the inequality and nothing really happens to it. All right. Here's the deal though. This multiplication by a constant is going to be a little bit tricky for some students. It's something you covered in Math 100, but it basically says this: you can multiply an inequality by any positive number. This is this thing over here, and there'll be no effect on the inequality. You'll see me go through examples on that. All right. Here's where students mess up. They mess up on this one over here. If you multiply by a negative number, right, when C is negative, the direction of the inequality changes. This is also incredibly important. Okay, we will do examples, but before we do examples, I want to go to the next section, which is going to be that polynomial inequality. So let me go to that. We'll talk through it. I know it's difficult. A lot of times students listen and say, I don't know why I need to listen. You really do need to pay attention to this. All right, I'm going to read it to you. No, I don't like reading this stuff over here. I'd rather be going through examples. But basically, we're going to be looking at what's called an analyzable polynomial. Now, what does that basically boil down to? That we can get into linear factors. We can get these into linear factors. Now, the bottom line is, why are linear factors so important? Linear factors are important because we know they're changing their signs at their zeros. So for example, the linear factor, I'll write this over here for you, x minus 3, that's a linear factor. It's a degree 1 factor. This would change signs when x is equal to 3. So for example, if I put a number line down, the number 3 down, if I looked at this thing and said, well, it's 0 at 3, but after 3, like if you chose 4, it would always be positive. That factor would always be positive. No matter what number you choose after 3, it's always a positive. Now, numbers below 3, like if you chose, like minus, I don't know, minus 1, you plugged it in, the factor would always turn out to be negative. So this is what's known as factor analysis, which is really what we're going to boil it down to. So let's talk about the technique. It's basically revolves around something really, really, really important. Let's talk about the first thing. First and foremost, you will need to have one side of your inequality set equal to 0. we will go through examples. Second thing you're going to be doing, and we'll go through examples, you need to have everything factored into linear factors, or what's known as an irreducible quadratic factor. I know that's a big word. Don't worry about it. We're looking for factoring just like you did in Math 100. Again, let me point out, equal to 0, completely factored. Then what do? And we'll go through examples. We're going to find all the zeros of the polynomial and arrange them in increasing order on a number line. That's incredibly important, that we're going to be listing all the zeros on the number line in increasing order. Then what are we going to do? We're going to do sign analysis by testing test points where they're not 0. Now, if they're not 0, what are they going to be? Either positive or negative. And we're going to be doing sign analysis. The next thing we're going to do is shade the regions where it's satisfied. That depends on the question. Is it greater than 0? What does that mean? Positive. If it's less than 0, what does that mean? It's negative. Final answers will be put down in interval notation. Again, we'll go through examples. This, for a lot of students, you're going to have to reread this many, many times to understand what's been stated to you. Through examples, though, we hope as you go back and reread this, that it starts to make more sense. What makes sense? Why we use 0, why we factor, why we use sign analysis, and ultimately, how do we get to the interval notation that we're looking for? Let's go to the next part of the lecture, which is going to be what's known as, oh, you know what? I'm going to go to examples instead. The next part of this section is not up yet, but we'll do that later. Let me go to the examples, and we'll start doing that. So give me 1 second.